Hello everyone. Welcome to week 5, practice problem number 2, all around student. Suppose a randomly chosen individual's verbal score capital X and quantitative score capital Y on a nationally administered aptitude exam have joined PDF as follows. Okay, so for the first problem, we want to find out if that individual taking this exam is more likely to score better on the verbal score or the quantitative part. So what we want to obtain here is what is the probability that capital X is greater than Y. That means this student's score will have the student's verbal score will be greater than the student's quantitative score. Okay, so so we are defined by this boundaries. So if we want to view the cross-sectional view of this joint PDF, for example, this is X, this is Y. Okay, we are bounded by this square. Okay, and we know that in this square, we have certain probability values defined by this piecewise function. Okay, so if we want to obtain probability x, capital X greater than Y, we have to define this line. This line is once again our x is equal to y line. If we want to define x greater than y, we are looking at this boundary or at this region. Okay, and this one is y greater than x. Okay, so you could just choose between the two, and the probability of this one is equal to 1 minus the probability of the other half. So y greater than x. So for example, we are choosing this boundary. If you want to get the probability, we just use the joint PDF here, and we just compute the integrals. Okay, so the probability that x greater than y is equal to the integral, double integration of the function 2/5 2x plus y 2x plus 3y integrated over y integrated over x. So if we are to integrate it first with respect to y, we are getting from this boundary to this boundary. So that is from 0 to x. And then if we integrate it with respect to x, we are getting from 0 from this boundary. But since we already integrated over y, we now integrate it from the lower bound, which is 0 to 1. Okay, let me just solve this integral. We are now getting from 0 to 1, okay, 4 over 5 xy plus 6 over 5 y squared over 2. We have to integrate it from y is 0 to y is x. Okay, so this is now from 0 to 1. Okay, y is x, so 4 over 5 x squared plus 6 over 5 x squared over 2 dx. Okay, and then we integrate now this one to with respect to x, so 4 over 5 x cubed over 3 plus 6 over 5 6 over 10 times x cubed over 3 integrated from x is 0 to x is 1. So we just substitute it. We now get, okay, 4 over 15 plus 6 over 30, which is equal to, okay, 8 plus 14 over 30 or 7 over 15. So this is the probability x greater than y. And now the probability that y is greater than x is equal to 1 minus 7 over 15, which is 8 over 15. So now, since probability y greater than x is greater than probability x greater than y, then the answer to the question is that the student is more likely to obtain a higher score in the quantitative more than its verbal score. So, quantitative greater than verbal score. Okay? Now, we proceed to the next problem. Are the two random variables independent of each other? Okay, so we can solve that by determining if the joint CDF is equal to the product of the marginals. So that's how we prove independence. So to do this, we just obtain first the marginals. So f sub x of x is from integral. So once again, we obtain the PDF 2/5 times 2x plus 3y, and then we integrate it with respect to y. Okay, so y here is from 0 to 1. So we obtain 4 over 5 xy plus 6 over 5 y squared over 2. From y is 0 to y is 1. We obtain 4 over 5 x plus 3 over 5. Okay, and this one is from 0 to 1. This is our marginal PDF of x. The marginal PDF of y is as follows. Integral from 0 to 1, 2 over 5 times 2x plus 3y integrated over x. So this is from 4 over 5 x squared over 2 plus 6 over 5 xy, right? Where x is between 0 and x is equal to 1. Okay? So this is equal to 2 over 5 plus 6 over 5y. Okay? Once again, this is y from 0 to 1. So this is now our marginal PDF of y. Now, we have to check if fxy of if the joint PDF is equal to the product of the marginals. So, and obviously, it is not, right? So, 4 over 5 x plus 3 over 5 multiplied by 2 over 5 plus 6 over 5y. This is not equal to 2 over 5 2x plus 3y. So therefore, x and y are not independent. Okay, we can conclude that already. Okay, if we have proven that the product of the marginals is not equal to the joint PDF, then we can automatically conclude this statement that x and y are not independent or are dependent from each other. Now finally, we can compute the covariance of x and y by using this formula. Expectation xy minus expectation of x, expectation of y. So we have to solve the expectations of x and expectations of y first. So this is equal to integral of x times the marginal PDF of x integrated over x from 0 to 1. So this is equal to 0 to 1 x times the marginal PDF of x is equal to 4 over 5x plus 3 over 5. 4 over 5x plus 3 over 5 integrated over x from 0 to 1, 4 over 5 x squared plus 3 over 5 x dx. This is 4 over 5 x cubed over 3 plus 3 over 5 x squared over 2 from 0 to 1. So we can obtain 4 over 15 plus 3 over 10. This is equal to 17 over 30. That is the expectation of x. You have to remember that, and conversely, expectation of y is equal to integral from 0 to 1 y, the marginal PDF of y integrated over y So this is 0 to 1 y times 2 over 5 plus 6 over 5 y integrated over y, 2 over 5 y plus 6 over 5 y squared integrated over y, 2 over 5 y squared over 2 plus 6 over 5 y cubed over 3 from y is 0 to y is 1. And we can obtain 1 over 5 plus 6 over 15, and this is equal to 9 over 15. So we remember this once again. We obtain expectation xy by using the joint PDF of x and y and integrating xy and this one. Integrated over dy dx, this is equal to from 0 to 1 and 0 to 1 xy 2 over 5 2x plus 3y from dy dx. Okay, 0 to 1, just simplify first. This is equal to 4 over 5 times x squared y plus 6 over 5 xy squared dy dx. And we have from 0 to 1, okay, integrate over y first, no? So this is equal to 4 over 5 x squared y squared over 2 plus 6 over 5 x y cubed over 3 evaluated from y is 0 and y is 1. This is equal to 0 to 1, okay, 4 over 5 x squared times 1 over 2 plus 6 over 5 x times 1 over 3, okay, integrated over x. So simplify once again, this is just equal to 2 over 5 x squared plus 2 over 5 x, and integrated over x, this is now equal to 2 over 5 x cubed over 3 plus 2 over 5 x squared over 2 evaluated from x is 0 to x is 1. We now obtain, okay, so this is 2 over 15 plus 2 over 10. This is equal to over 30, okay, 4 plus 6, 1 over 3. And finally, we can obtain covariance of xy by using the formula a while ago. So expectation xy minus expectation x, expectation y. So we have here 1 over 3 minus the expectation of x is obtained here, 17 over 30 and 9 over 15. 9 over 15. So we get, if we use our calculator, we will obtain the covariance of x and y is negative 1 over 50. The implication of covariance x and y equal to a negative number is that they are negatively related. That means that if x increases, then the possibility is y must also decrease. Okay, they have negative relationship, and the amount or the magnitude of that covariance is the amount of relationship between the two. So that just means that if a student's verbal score x tends to increase, then the student's quantitative score tends to decrease. So it just means that the student most likely cannot be better at both scores. Okay, so that's how you solve covariance in this problem. Thank you for listening and see you on the next problem.